There are almost no similarities between Earth and Jupiter. Ours is a sweet, small planet with plants and cute pandas. Jupiter is a giant gas horror with furious hurricanes which never subside. And if you fall into this planet, you might literally fly through it. But what would happen if our Earth was the size of the father of the solar system? Oh, this is going to be fun. Jupiter is a planet so big that I bet you can't even imagine its scale. Its radius is about 11 times the radius of Earth, and it's about 316 times more massive. So, to turn Earth into another Jupiter, we'd need to increase its radius by 11 times. If the planet's density remained the same, then the mass of our new Earth would increase greatly. Actually, it'd be as much as 4 times larger than Jupiter's. Of course, these changes wouldn't go smoothly. The very first thing that we would immediately notice, nope, not the size, gravity. It would increase by about 11 times compared to old Earth's. Scientists say we can actually survive on a planet with greater gravity, but only if it's less than 5 times stronger than what we have now. Well, let's assume that we're daredevils, always ready to challenge nature. What would our life be like? Well, not very pleasant. After each step, you'd have to sit down on a bench and take a break, as if you've just run a marathon. Yes, it would be that hard to walk. Oh, and good luck with getting up later. In order to somehow move around this planet, we'd have to pump up very strong muscles. No more problems with junk food, because you'd have to become a heavy lifter just to get to the refrigerator. The force of gravity affects not only movement, but also the size of everything. Do you know that many astronauts gain some height due to weightlessness in space? So if you're worried about being short, here's a solution for you. On the other hand, strong gravity would make us all shorter. This would go not only for humans, but for everything on our planet. Trees would become very small. To grow upward, they would have to move water from their roots to branches, which would be unrealistic with such gravity. So they'd all turn into little bushes. Also, no more mountains. Even the largest ones would become very small. But at least, now, everyone would be able to conquer Everest. This would also apply to animals. Our pets would have to quickly evolve into pumped-up corgis just to be able to walk somehow. Oh, and say goodbye to birds, of course. If you think that's not enough suffering, let's add another thing. It would be very difficult for us to breathe. Atmospheric pressure would increase dramatically. That's because Earth would start to pull air toward itself with great force. You'd literally feel the weight of it on your shoulders. Remember what I said about taking a break after each step? Now, imagine that you'd also have to breathe through a pillow. Yeah. And that's not all. Atmospheric pressure plays an important role in the behavior of water molecules. It would be much more difficult for water to boil or turn into ice. Most icebergs would melt, and it's possible that we'd have no more clouds, too. All water vapor would come crashing down on us in giant torrents of rain. We'd be lucky if we didn't get flooded instantly. But, oddly enough, there would also be some advantages. For example, everything around us would become much more spacious. Assuming we didn't get flooded, there would even be a bunch of deserted areas on the planet. Maybe land prices would finally fall. But these unexplored areas would most likely remain unexplored, since we'd hardly be able to travel across seas and oceans. Not only because moving across the water would be incredibly difficult, but also because all water bodies on the planet would become 10 times larger. The very thought of getting lost in the ocean is frightening, but imagine if it was 10 times deeper and bigger? Uh-oh. So, no more sailing. And forget about flying by plane, or visiting space ever again. But it seems like it's still not all. If Earth was the size of Jupiter, we'd also have volcanoes raging everywhere. Due to the increase in its mass, Earth would become terribly unstable. All extinct volcanoes would become active again. and there would be lava and poisonous gases everywhere. In 1883, there was the most destructive eruption in the history of humankind, the eruption of the Krakatoa volcano. It occurred on one small island, but people all over the planet could feel the consequences. The eruption destroyed the island, triggered many tsunamis, and clouds of poisonous gases spread for miles. Now imagine this, but 10 times worse. That's what would happen on our Jupiter-sized Earth. It would probably be similar to the fall of the Chicxulub meteorite, the one that wiped dinosaurs off the face of the Earth. Then, poisonous gases spread all over the planet, causing one of the greatest massive extinctions in the history of Earth. Oh, and we would also lose the magnetic field, like the cherry on top of the cake. The magnetic field is very important for life on Earth. According to Rory Barnes from the University of Washington, it shields life on the planet from the nastiness of space, which means all sorts of radiation and solar winds. There's a molten iron core inside our planet that is responsible for producing the magnetic field. If the amount of pressure on this core increased due to gravity, it could solidify. And because of this, Earth's magnetic field would disappear. We would be exposed to the effects of cosmic radiation. Too scary to even imagine. Alright, so now we know that living on this new Earth would be a real nightmare. But what about outer space? You've probably heard that Jupiter, thanks to its strong gravity, protects us from asteroids. Well, this would become our job. Jupiter experiences about 24,000 collisions a year, and now it'd be our destiny. Do you remember me mentioning the Chicxulub meteorite? Similar tragedies happen to our planet once every 100 million years or so. But if it became the size of Jupiter, these guys would visit us every Friday. Also, we'd have to say bye-bye to the moon. Our natural satellite is too close to us. So if Earth grew in size, it would be a real catastrophe. We would literally watch the moon being torn apart in the sky. Of course, after that, all these fragments would crash into us. One of the theories claims that billions of years ago, the moon somehow separated from Earth, and its pieces gathered into a ball. Now, it would be like watching its creation rewind. And even if the moon survived, somehow remaining in Earth's orbit, the changes in the tides would still be dramatic. The consequences of these changes would be very unpredictable, but probably a bunch of tsunamis would be some of them. On the other hand, we'd probably gain a couple of new moons. Jupiter has as many as 79 of them. It would probably be a spectacular view, if only gas clouds from all those volcanic eruptions didn't block it. Also, the appearance of a second giant planet would have significant consequences for the whole solar system. Don't worry, other planets wouldn't crash into us. Many people underestimate just how far the planets are from one another. But still, the new Earth would shift the orbits of other planets a little and affect the rotation speed. And Earth itself would rotate around the Sun much more slowly because of its huge mass. For example, 1 year equals 12 Earth years on Jupiter. All this, of course, would greatly affect seasons and the climate in general. So, would there be life on Earth? Bold of you to even ask this question. But if one day we do manage to find a habitable super-Earth close to Jupiter in size, it would be very interesting to take a look at it.
Yep, your brain will grow by roughly 2% if you venture into space. Under normal gravity, it is thought that fluid in the brain naturally moves downwards when we stand upright. But there is evidence that lack of gravity prevents this, which is why fluid accumulates in the brain and skull. While a bunch of flowers may be fragrant for you, there are people with cacosmia who would beg to differ. They perceive all the smells out there as something odorous. Well, that stinks. Speaking of which, out of all the senses we have, smell is the most acute one. We remember 65% of smells after a year, but only 50% of what we've seen over the last 3 weeks. We also get a new nose every 28 days, because the nose cells are renewed every 4 weeks. We don't smell when we sleep. Well, of course, unless you haven't bathed in a while. Your sense of smell goes to sleep when you do, which is why it's almost impossible to notice a gas leak at night. While sleeping, we rely only on sound because the sleep can be disrupted by noise. Almost half of your taste buds will have gone away by the time you turn 60. So maybe you will finally start eating those broccoli. Your sense of smell gets less acute as you get older as well. As for taste again, we mostly rely on our smell since it helps us perceive up to 95% of the flavor. Without the sense of smell, it'd be hard to tell an apple from a turnip. Now, when you cough, you release the air at about 60 miles per hour, so mind the speed limit. Hiccups is a two-step process. First, you draw in a lot of air because of a muscle spasm, and then bang! The airways are closed, the air is blocked, and the famous sound goes outside. We need ears, not only for hearing but for balance too. Our vestibular system occupies the inner ear. Canals in your inner ear contain fluid and tiny sensors helping you keep the balance. By the way, ears have bones. These are also the only bones that never grow. We can hear thanks to these little guys since they transmit sound vibrations. Doctors call them oscular chain, and it's made up of malleus, incus, and stapes, nicknamed hammer, anvil, and stirrup, which are integral parts of the middle ear. Our ears keep growing throughout our lives. They sweat too, and earwax is actually a kind of sweat they produce. Oh, by the way, the nose never stops growing either, perhaps from all the lies. Your heart is the only muscle that never gets tired. The aorta is massive. Its diameter is almost as large as a hose in your garden. All the bones in our body are connected to each other except for the hyoid, which doesn't articulate with the other bones. This bone serves as support to your tongue, and it's one of the rarest bones to break. If you have red eyes in a photo, blame it on bouncing light. The flash jumps off the capillaries in your retina, creating that effect. As for eyes, the coolest camera so far has 200 megapixels. The human eye has 576. That's why sunsets are so much better in real life than in photos. A roller coaster actually tosses your organs around. When you feel like your stomach's falling down, it's really flipping inside your body. Lips are much more sensitive than fingers, having around 1 million nerve endings. They are 100 times as sensitive as the tips of the fingers. Grooves and furrows make our lip print unique, just like fingerprints are. They also remain unchanged throughout our life. Oh, the tongue print is unique too, by the way. Even though all the people on Earth have an absolutely unique smell, identical twins smell exactly the same. It must be because they have identical genes. Usually, we shed about 50 to 150 hairs a day. An average lifespan for hair is 5 years, and as soon as an old hair says goodbye to your scalp, a new one starts growing immediately. In your body, you carry enough bacteria to fill a can. Bacteria makes about 3 to 5 pounds of your weight, representing 2% of your total weight. Still, most of them are the waste that our body has. A human being has about 20,000 to 25,000 genes. Seems impressive, right? Well, cornflakes have more genes than we do. Luckily, it's about sophistication, not the quantity. Anyway, cornflakes 1, humans 0. We consist of many chemical elements, including iron. The iron in our bodies is enough to produce 3 nails, each 1 inch long. The carbon that we have can be used for 900 pencils. Our feathers can be used to make quill pens. Wait, that's birds. Never mind. Our liver has a superpower of regenerating if part of it was removed. It can grow back to the size that your body needs. Fat helps our bodies consume vitamins. Such vitamins as A, D, K, and E can be properly absorbed only when fat dissolved. Our bodies have enough fat to produce 7 bars of soap. Don't try this at home. When we're awake, our brain may produce enough energy to turn an electric bulb on. It has 10 watts of power. What's that about? Our belly buttons have an entire animal encyclopedia in them, with a range of about 70 different bacteria. Some of them can be also found in the soil of Japan and even in polar ice caps. Our bodies actually glow. Anyway, we can't see that with an unaided eye because the light we emit is 1,000 times less intense than the minimum level we can perceive. Speaking of which, carmine used blushes and lipsticks is red dye made up of ground-up beetles. Oh. Saliva helps to taste food. Our taste buds are ready to perceive it only when it's dissolved by saliva. An eyelash is here to stay for 150 days only. The world eyelash record was about 3 inches long. They're also home for tiny mites. We blink about 4,200,000 times a year, at least once every 8 seconds. Could be cool if we were given a cent every time we blink. We could make more than $100 daily. It may sound crazy, but our bones are stronger than lots of building materials. A cubic inch of human bone can bear about 19,000 pounds, making it 4 times stronger than concrete. The only thing that makes our blood type different is sugar. A, B, and AB types have sugars, while O has none, which makes it perfect for donors. No sugar doesn't make O type less sweet. In fact, it attracts mosquitoes even more than the other blood types. People have only 8 blood types, while cows have 800 and possibly more. Like what? Mu positive and mu negative? Our fingernails grow way faster than toenails. They grow almost 4 times slower because they have less damage than fingernails. Even though we stumble on them often, sudden circulation bursts usually don't last long. Nails don't only help us catch random tiny objects and peel the stickers off. If you didn't have a rigid structure against which to press, you wouldn't be able to judge how firmly to hold anything. Very few people can actually digest milk. The thing is, there's some special enzyme, let's call it a little helper, that breaks down the sugars any milk has. When people grow up, they run out of this enzyme. This sugar's called lactose, so adults that can't digest it are lactose intolerant. 68% of the world's population can't actually digest milk. If you're sleeping, it doesn't mean your whole body rests. In fact, sometimes your brain has to work even harder when you're asleep. It needs to process tons of information, and reports usually take a lot of time. Humans can't multitask. Really? We need time to switch from one task to another, but if we try to tackle several things at the same time, it's not going to be very productive. Try this one. Lift your right foot and start rotating it in a clockwise direction. Try to write the number 6 with your big toe in the air. Now, check the direction your foot's moving. It's moving in the opposite direction because to write the number 6, you need to make a counterclockwise movement. It actually takes a bit longer to start a new habit. It's not 100% true that 18 or 21 days are enough, as many people think. The process of getting a new habit can take up to 254 days, but on average, it takes around 66 days for a new habit to become automatic.
Not unlike a giant cosmic blinker, a supermassive black hole 570 million light-years away flares every 114 days. Recently, astronomers have noticed powerful eruptions of light coming from the hole. The monstrosity is about 20 times the mass of the one at the center of our home Milky Way galaxy. So far, the only explanation scientists have is the black hole is ripping chunks of matter out of an orbiting star. It happens every time it gets too close. This discovery is rather exotic because no one has ever seen a black hole do something like that before. Usually, if a star comes close to a black hole, the space monster shreds it into thin strands, like spaghetti. After that, the black hole swallows most of the star's matter. The remains arc away in long, bright streamers. But not in this case. Every time the star approaches the black hole, it loses about 3 times the mass of Jupiter, and that's the largest planet in our solar system. This also results in a tremendous flare that astronomers can see on Earth. The flares are so regular and consistent that the researchers managed to predict several of them. They happened on September 6th and December 26th, 2020. A nebula is a cloud of dust and gas in outer space. You can see it in the night sky, either as a bright patch or, vice versa, a dark spot against some glowing matter. The Red Rectangle Nebula in the constellation Monoceros, or the Unicorn, is unlike others. Our universe has very few straight lines, and here you are, looking at a giant rectangle, which is a huge gaseous nebula, no less. And then, there's also the color, a bizarre shade of orange-red. Astronomers suppose the glow might be coming from some unusual activity inside the dust clusters. This activity is likely to be going on at the molecular level. The universe is around 13.8 billion years old, but HD 140283, a star informally called Methuselah, is apparently more than 14 billion years old. Even more paradoxical, the star has some chemical elements that are more typical for a second-generation star. Those are the ones formed from dust and gas left after the explosion of the first generation of stars. And still, the main problem is, how can a star be older than the universe itself? So far, the most likely explanation is an error in observations. It could make astronomers believe the star is older than it is. The star called Vega is relatively close to us, a mere 25 light-years away from the Sun. It's not the most usual star out there. It's brighter than it's supposed to be, and it's not round, but rather egg-shaped. Astronomers claim that's because the star rotates so fast, its shape changes. See for yourself. It takes the Sun 27 days to make a rotation, and Vega needs only 12.5 hours to turn on its axis. This speed also influences the temperatures on the star's surface. Its poles are several thousand degrees hotter than the equator. There's a supermassive black hole 250 million light-years away from Earth. It produces the deepest sound ever detected from any object in the universe. It's 1 quadrillion, which is 1 with 15 zeros, times deeper than what the human ear can hear. The Fermi bubbles confuse astronomers to no end. It's not every day that our home galaxy blows bubbles that are hotter than 7 million degrees Fahrenheit. Coming from the center of the Milky Way galaxy, the spheres are made up of nothing but powerful gamma rays. It would be a bit less strange should one bubble stay inside the other, with both of them at the center of the galaxy's core. But the two giant spheres hover independently above and below the black hole at the center of the Milky Way. Even more bizarre, they touch and form an hourglass shape. It makes the entire structure look like the number 8. The bubbles themselves are well-defined and slightly sharp-edged. They're also breathtakingly enormous, spanning a total length of 50,000 light-years. Scientists have yet to crack several mysteries connected with the Fermi bubbles, like what can produce such extreme energy? It's as powerful as 100,000 exploding supernovae. Or, what's with the off-center nature of the bubbles? Something must be going on there, even though it seems that the bubbles surround nothingness. K2-141b, a planet outside of our solar system, seems to be not that different from Earth. If you visited it, you'd see liquid oceans evaporating into the atmosphere. Just like on our home planet, the vapor then condenses and gets back to the surface as rain. But instead of water, all this happens with rock. The surface of the unusual exoplanet is covered with lava seas. In most places, they're tens of miles deep. And since the temperatures on the planet reach 5,000 degrees Fahrenheit during the day, the magma in the oceans vaporizes into the atmosphere. After that, supersonic winds, moving at a speed of 1 mile per second, carry the rock vapor to the planet's night side. There, the vaporized magma cools down, becomes liquid again, and falls to the surface as rocky rain. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. The planet completes one full orbit around the red dwarf Gliese 436 in 2 days, 15 hours, which means it travels remarkably close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet has huge volumes of water ice, known as Ice X. It remains solid despite blistering temperatures. Neutrinos are teeny, almost massless particles that can move at nearly the speed of light. They can easily pass even through metals and travel miles and miles without anything to stop them. You can be sure that some neutrinos are passing through your body right now while you're watching this video. These elusive subatomic particles get born in supernova explosions and in nuclear reactions inside stars. About 4,000 light-years away from Earth, in the constellation of Serpens, there's a bizarre planet. Astronomers think it could once be the core of a massive star, long gone now. 5 times the size of Earth, it seems to be one enormous diamond. The planet is denser than any other discovered so far and is made up of mostly carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Most stars move around the center of their galaxies following fixed orbits, but not HE 0437-5439. This 30-million-year-old star that appeared not far from the center of the Milky Way decided to set off on a journey. Astronomers think the star might have come across the supermassive black hole Sagittarius A star, and the space monster might have pushed the star out of the galaxy. It's now traveling through the Milky Way's outer halo, moving right into interstellar space at a speed of 1,600,000 miles per hour. Stellar halos surround galaxies and are home to stars and star clusters. This discovery turned out to be extremely confusing. Such short-lived massive stars, because tens or even hundreds of millions of years is a very young age for a star, aren't usually found in the halo. There, you can only encounter the oldest stars in our galaxy, those that are at least 10 billion years old. When disastrous magnetic field collisions occur at the sun's equator, they cause ginormous tsunamis of plasma. These tsunamis move across the star's surface at a speed of 1,000 feet per second. Such a tsunami can last for weeks at a time. They happen almost every decade. More than 7,000 light-years away from Earth, there is the Eagle Nebula. It's a young cluster of stars, just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called pillars of creation, towering tendrils of interstellar gas and dust. They're also a part of the nebula's active star-forming region. Newborn stars are hidden in these wispy columns. Unlike their supermassive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. But even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims tons of micro black holes could have appeared right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that several mini black holes pass through our planet every day, totally unnoticed. Scientists think white holes might exist, even though none has been found yet. When some space object comes across a white hole, it can't enter it from the outside, but light and matter can escape from within the hole.